Hello guys, welcome back, and in this video we will be discovering and understanding testing of hypothesis in a much more elegant way. We will understand why it exists, how it exists, what's the purpose, and we'll give an overview of the whole topic um, in a frame by frame, in a flow by flow manner. That means we will create a story out of it. So let's imagine that you have two Bernoulli toss, that you toss a coin twice. So x1, oops, you have x1 and x2, which follows Bernoulli p. So this is the model framework. This is the model of the whole. This is a model that you're assuming that x1, x2 follows some Bernoulli, some distribution Bernoulli p. This is unknown. The goal of statistical estimation, the goal of statistical estimation was to find So the goal of statistical estimation was to use this data set to get a best estimator out of P, which is a function of this data, and also which is close to the actual parameter, unknown parameter. So this was the goal. And we have seen the various ways to do it. So we have seen that how to do it, and we have seen that the result that we got in how, why that is a good thing. What are the good things, what are the good properties of an estimate, and we have seen some good really properties of an estimate, some good really estimates. That's what the whole purpose of statistical estimation, right? Now, what is testing of hypothesis? In testing of hypothesis, we have a same model, right? But we have some questions. We may not need to know the exact value of the estimate we had. Rather, we have some other questions. We can ask, instead of asking, what is the value of the estimate? We can ask a very specific, uh, a bit loose amount of, to loose to a certain degree type of questions, like questions like, is p equal to half? Is p greater than half? Is p less than half? Or let's say, is p less than half, or p greater than 3/4? Questions like this. We can ask questions like this. The question is that how can you make sure the data supports this? Or so this is questions. These are called hypotheses. So we can have hypotheses like this. Okay. But there's something called, so we can have questions, hypothesis. But there's something called like testing of hypothesis. Hypothesis is much more to that. It's a tug of war between two hypotheses. So there are two hypotheses, to be very honest. One is called null hypothesis, one is called alternate hypothesis. The goal is that the goal is that if the data either supports the null hypothesis or does not support the null hypothesis. So if the data does not support the null hypothesis, then what alternate hypothesis it will support? That's the question. But there's much more deeper understanding to this. It's like if you have gone into a if you have gone into a judgment trial in a court, you will see that the corresponding criminal is being either, so it's told that we have, so it's said like this: we do not have enough evidence to show the person guilty. We have enough evidence to show the person guilty. So the question is that the idea is that we are using the data to test whether these we have enough evidence to show the person is guilty, or we don't have enough evidence to show the person is not guilty. So if we remove this to show the person guilty, this is the aspect of to show the null hypothesis. It's kind of very central. But also it comes with alternate hypothesis, and we'll see how it plays a role. So there are two aspects to it. So one such example to it is that, like, there are two aspects to a testing hypothesis. One is a null hypothesis, one is an alternate hypothesis. So we will make a proper philosophical, proper logical discussion in another video. Like, video is meant for understanding an overview of testing hypothesis, understanding the nitty gritties. So we have the data and model, and from data and model we get the null hypothesis, which is called H naught, and the alternate hypothesis, H1. So an example in this, I will write an example in that. So x1, x2 follows Bernoulli P. Null hypothesis may be P is equal to half, and alternate hypothesis may be P greater than half. So any hypothesis can be of various format. It can be of simple hypothesis when it's equal to just one single number, or it can be of composite hypothesis when it's not simple. Okay. So there are simple versus and composite hypothesis. So yeah, that's important because we'll see how it how it plays a role in the future. So now understand that we have a null hypothesis H and an alternate hypothesis H1. The examples are given. Now how to answer after this? The next step is the following. Is that so let so what do we mean by a testing of hypothesis? This is where it comes, right? Like, that's the idea. What is the meaning of testing a hypothesis? That is where we are coming to right now. So one may say intuitively that if the number of if the number of the number of this is one example. Now this is what is called the rejection criterion, test criterion, you can say. Now what exactly is the test criterion? The test criterion is, less one example can be reject h naught if x1 plus x2, the total number, what is x1 plus x2? X1 plus x2, x1 plus x2 is nothing but the total number of heads, okay? A total number of ones observed in Bernoulli x1 and x2, like two tosses. Total number of ones. If x1 and x2 is greater than 1, that means here it's equal to 2, rejected. Okay. Understand, we can also write this as in other ways, other different ways. Why are we not rejecting x1, x2? Reject h naught if x1, x2 is equal to 0. Understand, we are not doing this, due to a very specific reason. Why? Because this also tells you that it's very extreme. Like x1 plus x2 is equal to is very extreme among these two tosses, right? X1 plus x1 plus x2 is equal to 0 is also very extreme. But understand, when we are rejecting, the rejection of h naught, the rejection of this null hypothesis must also support the alternate hypothesis h1, right? If we take the blue one, it will not support h1, that p is greater than half, because x1 plus x2 is really low. Like it should be, if its p is greater than half, it should be more than, you know, it should be more towards on the um like x1 plus x2 should be more, x1 and x2 should occur more, hence x1 plus x2 should be more, the value should be like, it will be most probably more 1 than 0. So therefore the hypothesis not only has a role to play in the rejection of h naught, but also it has a role to play in the acceptance of h1 or in support of h1. Remember that. So and therefore we see, so therefore we can have other criteria also. We can have criteria like reject h1 h naught if x1 plus x2 is equal to 1, or greater than 0, or whatever. Like you can have different criterias, right? You can also have criteria like reject h naught if x1 plus x2 is greater than 0. Different criterions, right? Test criterions. But what does it mean essentially? So if you observe, let's sort of plot it. If you observe, if you observe, let's say x1 and x2 here, x1 and x2 can take 0 or 1 value, right? So therefore x1 and x2 together can take these four values, both 0 0, x1 0, x2 0, x1 0 1, x2 0. Here x1 0, x2 1, and here both 1. So observe that if, let's take this yellow, this blue, or let's take this red one. Okay, let me write this in green. Okay, If you take this red one, this red region is x1 plus x2 is equal to, then only reject h naught, right? Then observe that it's same as telling that reject h naught if this and only so. Reject h naught if this happens, and if none accept otherwise. So therefore, right is like tick is that it's accepting the, if it's cross cross that means it's rejecting. So essentially what is happening, what is this diagram that we have done? It's nothing but the sample space of the model of the data x1 comma x2, the data, the all possible outcomes of the data. Out of that we are saying that if this is happening then it's rejection, if this is happening, if the yellow is happening it's acceptance of the h naught, or we do not have enough data to reject the null hypothesis. Okay, the yellow region, the yellow region is saying that it's not being rejected, so we say that we do not have enough data or evidence to show that, to reject the null hypothesis, to show that the person is guilty. So null hypothesis is similar like showing like the person is not guilty. So therefore the idea is that the test region is nothing but test criterion is equivalent to selecting or equivalent to partitioning the sample space of the data is equivalent to partitioning sample space of the data, which is into two halves. In one half it's rejected, in the other half it's not rejected. What is not rejected? Null hypothesis h naught. One. Since h1 is the alternate hypothesis, same as saying that h1 is accepted if h0 is rejected. So therefore in yellow region, so the yellow region is the h0 not rejected region, this region, and the gray region is the h0 rejected region and h1 accepted region, as you can understand. So therefore test criteria can be written as mathematically as phi of any x curl the data is nothing but 1, it's acceptance or rejection, right, is 1 if x curl belongs to some region R, the rejection region. 1 is rejection and 0 is not rejection if does not belong to R. This is the basic idea. There's certain extension to this called randomized test, which will be an aspect of another video. But the goal is this, that test criterion is nothing but a partitioning of the samples for the data, where we are saying that if it lies on this side, it's we are rejecting the whole null hypothesis. If it's lying on the other side, we're accepting the whole null hypothesis, or we are not rejecting the whole null hypothesis, rather we are accepting the h1. So the idea is this, right? The idea is this. So now you can see there are many ways of partitioning the data set. We have seen four examples here, right? One, two, three, four. The question is that, so there are many ways to partition the whole data set, right? That's only the definition of a test. The question is that which is the best partitioning? Which is the best test? And this question will lead us to the idea of how do we find the best test for a given model and a hypothesis. So model and hypothesis is given. We are now going to, we know what is the test hypo, the rejection region. We know what is the test criteria. The goal is to find the best rejection region, and the best rejection region is equivalent to the best test. But how do we measure a test, which test is bad or which test is good? And that will be the goal of the next video. Thank you. I will see you in the next video. Stay tuned and stay blessed.